Andy Wheeler. What I'm going to show you guys today is a web-based application I've created to help you plan and experiment to see if what you're doing is reducing crime. So for a hypothetical example, pretend that you wanted to target burglaries of motor vehicles in a Walmart parking lot in your jurisdiction. So say that Walmart parking lot tended to have around 10 BMVs a month. Here, my suggestion is to not just have that treated area where you're going to do your intervention, say do extra patrols, put out flyers, have Walmart hire security, whatever that may be. But you also have an additional control unit. So say parking lots in other parts of the city or another larger grocery store or things like that. And so you're comparing that control area to the treated area. So that's step one. Step two is you need to know, or you should know, how long you think you should do that intervention before you can tell if it's actually working or not. If crime's rare, or you don't think that you'll reduce crime all that much, hotspots policing typically only reduces crime by around 20%. You'll need to conduct that experiment longer to see if it's actually working. So in that hypothetical 10 BMVs a month scenario, if you just do it for 1 month and you see that next month it's 6 BMVs, that's not really very good evidence that it actually reduced crime. So having that control area and then examining those differences over a longer period of time gives you much stronger evidence. Basically, your estimate of how well your intervention works gets more precise over time. So what I'm going to show you today is how to use this web application that I've created to basically say, okay, we should do this evaluation or plan to do this intervention for 3 months or 6 months or 12 months or however long. So here I'm on my CrimeDe-Coder.com website. If you go up to content and click demos, scroll down to the bottom, I have an experiment planning tool that you can use. So this is just a free web-based application. So all you need in this particular scenario are 2 numbers. So number 1 is the number of crimes you expect that are in your treated and control locations on average. So I gave the hypothetical example of 10 crimes in our Walmart parking lot. Again, you should have basically a control area. It doesn't necessarily need to be a randomized control area. Most police departments aren't going to be able to do that, but you should have a control area that has the approximately same trends over time. Like I said, another parking lot or even a combination of multiple other parking lots would be like a good control area in this hypothetical example. And then we also want to see how much you can reduce crime. And so this is a guess. So you're guessing offhand how much you think your intervention will reduce crime. Here I'm going to guess 3, and then you can just go ahead and click calculate and plot here. And what this graph shows is in our hypothetical scenario, not only our cumulative crime reduction over time, so -3 month 1, -6 month 2, it also shows these error bands are an estimate of the standard error around that crime reduction over time. And so you can see that in this particular scenario, it ends up taking us around 6 months before that standard error doesn't cover that 0 line for us to know whether it's likely that our intervention is actually reducing crime. So these are hypothetical scenarios, but that's how you essentially plan how long you should do this intervention. So in this scenario, say you're planning with your chief, these extra resources to do these patrols or whatever you're doing in that parking lot, you should basically say going in, well, I think we're going to need to do this at least 6 months before we can see if there's sufficient evidence to see if it's reducing crime. Now, I'm going to show a little bit more technical stuff, but that's the main that's the main gist of what I'm showing here, is that you can put in your own baseline counts of crime, how much you think crime is going to be reduced, and then see how long you should plan out that particular experiment. It ends up being, if the baseline counts are lower, or you don't think you can reduce crime as much, you're going to have to do your experiment longer. So think, if we can only reduce one crime a month instead of 3, we have to go out, we have to plan for much longer in this scenario. And here, even after 2 years, we don't necessarily think we could show those crime reductions. So if you think, if it's 10 crimes per month, this would end up being 240 crimes in your treated area or in your control area, and this would only be 240 minus 24 in your treated area. So it's a smaller difference over time, essentially, and so you need to plan out to do that a little bit longer. For some more technical material here, if you're a researcher and want to see the underlying methodology for this, you can come down to the bottom of the code and see the bottom of the web page, I should say, and it'll show the R code. What's happening is, behind the scene, this is actually running R code just on your particular computer, and then just making this nice graph for you. So you can basically just go and copy that and put it right into your grant application or project plan or anything like that if you want to. If you want to see a few more of the mathematical details, if you go click the help button, I have all the different papers that I've done. This is derivative work that I've done with Jerry Radcliffe on a simple weighted displacement difference test. And then also I have a GitHub repo that goes into a little bit more of the mathematical details and equations and everything else if you actually want that. The last thing that I'm going to show in this particular video is that scenario that I just did, 10 baseline crimes, so you have treated and controlled, reduced it down to 3. So on average, it'd basically be going from 10 to 7 over time. You can also incorporate historical data, which a lot of times is good, and it can, in some scenarios, you can have a lot of, so say you could look at the trends over time in that Walmart parking lot and in those other parking lots and see, like, well, they look like that they've trended up and down over time, very consistently over the past, say, decade. It's not uncommon to find very historically consistent areas of crime in cities like that. So that's what's called the parallel trends assumption. You can basically incorporate that historical data into the analysis. So say that we have a prior 5 years, so, and this is per month, so 60 months. We can incorporate that into our estimates and see if that'll actually, like, help us identify this crime reduction over time. And so when you incorporate historical data like that into the estimate, it changes the nature of the estimate a little bit, and it still ends up being 6 months here. But really, you're looking at it at a per unit time. So we can see that it's not a cumulatively reducing estimate over time, but essentially we think that we're reducing 3, but our standard error for that turns into a funnel, and basically that estimate shrinks down over time. And so those are the 2 scenarios with estimating an actual crime count reduction over time. I'm going to make a couple additional videos to show off some of the other tools here, which includes estimating a percentage reduction or estimating a differences in percentage reduction in crime count. So instead of saying 10 to 7, it's like saying a 30% reduction essentially. And then another one is looking at rates per event. So say you have an intervention that you want to reduce officer use of force, or you want to increase arrest or clearance rates. I have a few different tools that are similar, to help you plan out those types of interventions.